The Blockchain Factory: Zero Waste, Zero Defects. Transforming industrial production through distributed ledger technology, artificial intelligence, and circular economy principles to achieve unprecedented efficiency and environmental responsibility. Manufacturing waste contributes to billions in lost resources annually, worsening environmental damage and threatening long-term sustainability. Defects in production lead to major financial losses, resource inefficiency, and reduced competitiveness across industries. The traditional linear, take, make, dispose, economic model amplifies these problems and cannot be sustained. To secure future success, businesses must transition towards circular, regenerative models that eliminate waste and defects. Nearly one-third of global food is lost before reaching consumers due to supply chain inefficiencies. This waste contributes to greenhouse gas emissions and depletes critical resources, while millions continue to suffer from food insecurity. Each year, around 1.3 billion tons of food is wasted. The economic toll is staggering, amounting to approximately $1 trillion annually. Some factories, such as those in the automotive industry, have historically experienced defect rates as high as 50%, creating severe inefficiencies. These high defect levels result in costly recalls and extensive rework efforts. Beyond financial losses, they also erode customer trust and satisfaction. Altogether, defects cost industries billions annually in both direct and long-term impacts. Blockchain provides immutable transparency by recording every supply chain transaction in a decentralized, tamper-proof ledger. This ensures full visibility and accountability across all process steps. Real-time tracking enables early detection of inefficiencies and waste points, improving decision-making throughout the value chain. Additionally, token-based incentive systems financially reward stakeholders for achieving measurable waste reduction and efficiency gains. Before blockchain, Walmart needed 7 days to trace food products through its complex supply chains, often making interventions too late to reduce waste. With IBM's Food Trust blockchain, this tracing time dropped to just 2 seconds. The rapid access to complete product data allows faster responses to prevent spoilage and contamination. This success highlights blockchain's transformative potential to pinpoint waste sources and save millions of tons of food annually. Fishcoin introduces a token-based system that rewards stakeholders for sharing essential data, bringing transparency to seafood sourcing and distribution. This approach tackles the problem of up to 60% of seafood being discarded due to inefficient supply chains. By incentivizing participation, it encourages ethical sourcing and responsible practices. Ultimately, the platform drives more sustainable consumption patterns across the seafood industry. Industry 4.0 technologies are driving the shift towards zero-defect production through advanced connectivity and analytics. IoT sensors provide real-time monitoring to detect and prevent defects as processes unfold. AI analyzes production patterns to predict potential issues before they occur, reducing costly errors. Blockchain ensures transparent, tamper-proof records of all quality processes. Together with digital twins, these tools create full, real-time visibility across manufacturing operations, revolutionizing efficiency and reliability. A blockchain-integrated IoT system uses deep learning to analyze sensor data and detect casting defects with exceptional accuracy and speed. Blockchain provides secure, tamper-proof records that protect data integrity across the production lifecycle. This transparency ensures trust and accountability in operations. Additionally, automated reporting streamlines regulatory compliance and helps manufacturers meet strict industry standards. German small and medium enterprises lose around €47 billion annually due to production defects, highlighting severe inefficiencies in manufacturing. These defects not only drain financial resources but also weaken competitiveness. By using transparent digital twins integrated with blockchain, companies can enable predictive analytics and real-time quality monitoring. Such tools make it possible to detect faults early in the process. This prevention strategy reduces the risk of recalls and minimizes costly repair processes. Blockchain currently consumes about 0.5% of global electricity, much of it from fossil fuels, creating significant environmental concerns. Transitioning to energy-efficient consensus mechanisms like proof of stake can greatly cut its carbon footprint. Beyond reducing impact, blockchain also supports renewable energy trading between producers and consumers. Additionally, it enables transparent tracking and verification of carbon credits to strengthen sustainability efforts. Blockchain enables a circular economy by turning waste into valuable inputs for new production cycles. Full life cycle tracking ensures materials are efficiently reused and recycled. Smart contracts automate waste diversion processes, maximizing resource utilization without human intervention. Token-based incentives encourage sustainable practices throughout the supply chain. Interface Inc. has reduced manufacturing waste by 84% since 1996, achieving a 91% total waste reduction across operations. Unilever has reached zero non-hazardous waste to landfill at over 600 manufacturing sites worldwide. These examples show that zero-waste manufacturing is both achievable and profitable on a global scale. A zero-waste company relies on several key pillars to achieve sustainability. Digital tools provide transparency and support data-driven decision-making. Engaged employees are essential, participating actively in waste reduction initiatives. Adopting circular economy practices ensures responsible sourcing and the reuse of materials. Waste reduction at the source is achieved through optimized production processes and intelligent product design. The blockchain factory vision integrates multiple advanced technologies to transform manufacturing. At its core, a distributed ledger ensures secure, transparent, and tamper-proof records. IoT sensor networks provide real-time monitoring of all production processes. AI analytics enable intelligent automation, predicting and preventing defects before they occur. Industry 4.0 principles support smart manufacturing, aiming for perfect quality control and zero defects. Together, these systems maximize resource efficiency, driving the goal of zero waste across operations. In the blockchain factory, every product and process is represented as a digital twin on the distributed ledger, providing full visibility and control. Real-time alerts allow instant defect detection and automated corrective actions to prevent waste. Tokenized incentives reward stakeholders for improving quality and reducing waste. This system fosters continuous improvement and operational efficiency across the entire production network. The blockchain factory model generates significant cost savings in material use, waste disposal, and brand value. It also reduces greenhouse gas emissions and conserves resources. Overall, it delivers both economic and environmental benefits across manufacturing operations. Blockchain faces high energy consumption, which can be mitigated through green consensus mechanisms and renewable energy use. Aligning stakeholders requires transparent incentives and education programs to unify sustainability goals across the supply chain. Integrating legacy systems with modern digital platforms ensures seamless adoption of blockchain technologies. Together, these solutions address operational, environmental, and organizational challenges in implementing advanced manufacturing systems. Manufacturers are urged to adopt blockchain and Industry 4.0 solutions to enhance efficiency and secure a competitive edge. Transparent collaboration across supply chains fosters accountability and shared sustainability goals. Investing in innovative technologies drives both profitability and environmental protection. Taking these steps ensures a future-ready, responsible manufacturing ecosystem. Blockchain factories exemplify the future of sustainable manufacturing by integrating advanced technology with visionary leadership. They enable circular, defect-free operations that promote both innovation and efficiency. These factories aim to eliminate waste and defects, ensuring responsible use of resources. Collectively, they pave the way for a sustainable future for manufacturing and the planet. Please like, subscribe, and join me in the next video.